Alright, welcome back. Now, in the second video about limits, we're going to just be talking about more ways to evaluate them, and a specific one called the conjugate. So, when it comes to limits, there's 3/4 main ways depending on how you think about it. The first one is just plug it in, see what happens. It's the easiest one. You don't really complain about it too much. Then the second way is just solve certain kinds of algebra. I believe that's like the most common. And you could argue that the conjugate falls underneath that because it is just algebra, but it's something you'll probably be seeing for the first time here, assuming you haven't like done any crazy algebra before. Now, I'm going to cover up to that in this video. The third is called squeeze theorem. That's going to get a video on its own later on. It's sort of like popping a pimple. You'll see what I mean when I get to it. And number 5, and one of the more useful ones actually, is called the L'Hopital's rule, but that involves derivatives. So it's just sort of like, you'll have to hold off on that, but we will come back to that. All right, so let's just do something as a quick refresher of how to do a limit, and then we'll move on to new stuff. All right, we have the limit as x goes to 1 of 2 times x squared minus 8x plus 4. Okay, well, as always, your first, idea should be to just plug it in and see what happens. Okay, well, where are our x's? Our x's are here and here, right? So we're going to have 2 times 1 squared minus 8 times 1 plus 4, right? 1 squared is 1. Minus 8 times 1, which is just 8, so that's negative 7, plus 4 is negative 3. So for this, we get negative 6. All right? Not too crazy. We could have broken it down with all the limit laws. It would just be the same answer, right? So let's move on to some more new stuff, some more interesting things, in my opinion. All right, so we have the limit as x goes to 1 of x squared minus 1 over 1. Let's just plug it in and see what happens, right? Well, we get 1 squared minus 1 over 1 minus 1. That equals 1 squared is 1, so 0 over 0. All right, that's 0. We're done. Easy limit? No. This is called an indeterminate form. It just means that what you did is technically right, but technically wrong, so you have to manipulate it in certain ways to get the correct value, right? So let's see what we can do. Well, the issue is that we're dividing by 0, right? Let's see if we can use algebra to simplify our limit. Okay, well, we can't really do anything to the bottom. It's just going to be x minus 1. And we have x squared minus 1 on the top. Let's think. We can factor that, right? So we can get the limit at still x goes to 1 of, if we factor this out, we get, this is a perfect square, so we have a squared plus or minus, just minus b squared. This is just going to equal a plus b times a minus b, right? Which just means this becomes x minus 1 times x plus 1 all over x minus 1, right? Okay, well, because we're multiplying and then dividing by x minus 1, we can just go cancel, cancel. We have not taken a limit, so it's still there, of x plus 1. All right, well, we just did some algebra. Let's go back and see if we can just plug it in, right? Where are x? X is here, so we'll have to plug in x equals 1 here, so this becomes 1 plus 1, and that equals 2, right? So when you can factor it out, if you get an indeterminate form, you can then hopefully get a nicer, concise answer. And this makes sense, right? We didn't really change the value of it, we just changed how it looked. All right. Now, one thing I will say, and this will come up in a video or two, is the function does not exist at x equals 1, but the limit does. That'll make sense later, but think about it. If we plug in x equals 1 here and here, these two are equivalent expressions. Here, we get 0 over 0. Here, we get 2, right? So something's up there because 0 does not equal 2. Or 0 over 0 does not equal 2. So, yeah. Let's move on to another more challenging example of the same idea. Alright, so we have this limit as x goes to 3 of x squared plus 4x minus 21 over x squared minus 8x plus 15. Let's just plug it in, see what happens, right? We get, well, 9 is 3 squared plus 12 minus 21 over 9. 8 times 3 is 24 plus 15. Okay, let's see. Well, let's just do it. 9 plus 12, 21, minus 21, 0, right? 9 plus 15, 24, minus 24, 0. Oh, crap. So once again, we got 0 over 0. That's no bueno. So, since we got 0 over 0, we obviously have to factor this because that's what we're focusing on right now, right? So we have this top polynomial. They have to multiply to 21 and add to 4, right? Well, what are the factors of 21? 1 and 21, right? It's an odd, so you can't multiply by 2. Is there something that multiplies by 3? Yeah, 7. Something by 4? No. It's not by 5, not by 6. So yeah, this is it. Right? And we know one of them has to be negative because we're trying to get negative 21. And they have to add up to 4. So, obviously these aren't going to in any which way add up to 4. But if we have plus 7 minus 3, we get negative 21 when multiplying and plus 4 when adding. So, this top polynomial is actually just x minus 3 times x plus 7. Right? And now let's do the same thing for the bottom. They have to multiply to 15 and add up to negative 8. Well, 1 and 15, 3 and 5, and those are the factors. Again, these aren't going to add up to negative 8 in any which way, but these two are when they're negative. So we'll get x minus 3, x minus 5. Awesome. Once again, cancel these out, rewrite it, keep your limit notation. If you are taking AP calculus or if your professor's a bit of a stickler, I would always recommend keeping this because it's an easy way to lose points until the very end. It's annoying to rewrite, yes, but it's better to rewrite and lose a point. All right, so now we did algebra. We go back to step 1, plug it in. We get 3 plus 7 over 3 minus 5. This is 10 over negative 2 equals negative 5. And that's the answer for this example here. Not too bad. Just make sure you brush up on factoring. Now let's do one more example of this with less explanations by me so you can check to see your understanding. Alright, so we have the limit as x goes to 10 of x squared plus 4x minus 21 over x squared minus 2x minus 15. Please pause the video, give this a shot. You can do it, right? It's not anything crazy new. We've done examples before. Just view your algebra fine. You got this. Alright, now that you've finished it, let's go through it. Your first step should have been to just plug it in, right? You get 10 squared plus 4 times 10 minus 21 over 10 squared minus 2 times 10 minus 15. Okay, so this is going to be 100 plus 40 minus 21 over 100 minus 20 minus 15, which is 140 minus 21 over 100 minus 35. Okay, this Now this is going to be the tricky math that I'm going to hopefully not fail. 119 over 65? Yeah, 65. Now, this is correct, right? But why didn't we have to factor? Because you do not have to factor when you see polynomials every single time. You only need to factor if you realize, hey, I plugged it in, I got an indeterminate, something was wrong, right? Which is why you always want to plug it in first. If you went straight to factoring and you still got the same result, you still got the same result. However, you've probably spent more time factoring than you could have when you just plugged it in. Like, that was the whole idea behind this example, is check to see if you're just blindly following what we did last, or thinking about, okay, do I want to go straight to that, or is there something I can do beforehand that might get me the answer? All right, now with that out the way, let's go to something most likely brand new for you called the conjugate. All right, now this is our first example using what is called the conjugate, right? The conjugate comes into play when you have a radical like this, right? So, as always, let's just plug it in, see what happens. X equals, or X is the limit as X goes to 4, and we have an X here and here. We get square root 4 minus 2 over 4 minus 4. Square root of 4 is 2, minus 2 is 0, 4 minus 4 is 0, and yep, 0 over 0. Okay, well, let's just do the conjugate. So in this case, we have the limit as X goes to 4 of the square root of X minus 2 over X minus 4. Nothing new. We're going to multiply this whole expression, right, by the square root of X plus 2 over itself. All right? Because technically, this is equal to 1. So we're multiplying by 1, which does not change the limit, right? It changes how the limit looks, but not how it, like, behaves, right? So that means we get the limit, X goes to 4, of square root of X minus 2 times square root of X plus 2 over X minus 4 times square root of X plus 2. All right? Now, if you recall from 2 examples ago, we said that if you have a squared minus b squared, that's the same thing as a plus b times a minus b. And that goes both ways. If you have a plus b times a minus b, that equals a squared minus b squared, right? Now we're going to use this in our limit here, right? Because we have square root of x minus 2 times square root of x plus 2. So we have a minus b times a plus b, which is just going to equal square root of x squared, which is just going to be x, minus 2 squared, which is going to be 4. And then we're not going to do any algebra on the bottom. Right? Now, if you don't remember this, that's perfectly fine. You can multiply this out and you'll get the same value. Now, another piece of advice when you're doing the conjugate, do not simplify the denominator until you absolutely have to. Why? Because now look, it's very obvious that the top cancels out with the original denominator. And so you get the limit of x going to 4 of 1 over square root of x plus 2. Right? And well, we just did a bunch of algebra. Let's go back to step 1 and plug it in. Right? Well, we only have x on the bottom and then square root. So we get 1 divided by the square root of x, right? X goes to 4, so it's square root of 4, which is 2, plus 2. So this limit equals a fourth. Okay, quick recap as to what we just did. We had this limit up here. We plugged it in, we got 0 over 0. No bueno. So we multiplied by 1, except the 1 looks really fancy because it's the radical. You flip the sign and you keep the rest, right? Over itself, because this is just 1. So we had this big expression. We realized that the top can simplify out to this, and we did that. And then what we simplified to was actually the original denominator, so we could cancel stuff out and get a very nice, clean expression. Then we did all that work to go back to square one, which is plug it in. And when we did, we got 1/4, and that is the answer. All right, let's do another example. And this time, we'll see how it goes. But it'll be a bit harder than last time. All right, nothing too crazy. All right, now for this next example, we have the limit as x goes to -3 of the square root of x plus 4 and square root minus 1 quantity over x plus 3. This is a nasty looking plus sign. Let's fix it a bit. All right, so as always, plug it in, see what happens. Square root -3 plus 4 minus 1 over -3 plus 3. Well, the bottom's going to be 0, I can tell you that, right? -3 plus 4 is 1. Square root of 1 is 1. 1 minus 1 is 0. Yep, it goes to 0 over 0. If only every limit just went to 0, but not 0 over 0. But oh well. All right, the conjugate. Well, I'm going to give you a second to think. Okay, what is the conjugate of this going to be? As I rewrite the expression. Get your answer? All right, let's compare answers. I got that the conjugate was going to be the square root of x plus 4, right, plus 1 over itself. Right? Because what the conjugate is, you keep everything the same, except you flip the sign here. And then you divide by itself. Okay, let's multiply this out. Limit x goes to 3 of, well, once again, we have these pairs, It's almost like that's the main idea of the conjugate. If you multiply by it's actually called its conjugate pair, right? Now it becomes really simple multiplication and it'll cancel out. So you get the first term squared, right, minus the second term squared over all of that mumbo jumbo. Okay, well, we can always simplify a bit more. Well, if we look here, we have x plus 4 minus 1. 4 minus 1 is just 3, right? And then we have an x plus 3 on the top. That's going to cancel out with the x plus 3 on the bottom. So we get 1 over square root x plus 4 plus 1. And now we did all that algebra. Let's plug it in, see what happens. Also, one thing I've almost messed up is the limit goes to -3, not +3. All right? So this, we get square root of -3 plus 4, that's 1, plus 1, 2. So we get 1/2 as our final answer. Awesome. All right? Now, just remember the main thing about the conjugate, you don't do anything besides flip the sign here, and it's highly recommended you don't do all of this algebra on the denominator as well, because something should cancel out, hopefully. All right, one more example that you mostly do, so let's get to it. All right, we have the limit as x goes to 9 of x minus 9 over square root of x minus 3. All right, give it a shot, do your work, see what you get. I'll give you a minute. All right, hope you paused the video, but now let's get to it. Well, when we plug it in, we get 0 over 0, right? 9 minus 9, 0. Square root of 9 is 3 minus 3, 0. Well, conjugate time. Limit, x still goes to 9 of x minus 9 over square root x minus 3 times square root x plus 3 over square root x plus 3. Same limit, right? You get x minus 9, quantity times square root x plus 3, all over x minus 9. Cancels out. You're left with a limit. X goes to 9 of the square root of x plus 3. Now we go back to square 1, which is plugging it in. Square root of 9 is 3, plus 3 is 6. So this limit actually equals 6. If you got the same answer, good job. This was the first time that you saw the radical on the bottom. It doesn't matter if it's on the bottom or top, it just matters that there's a radical for this to work. So yeah, good job. All right, so let's just do a quick recap of everything we've done in this video. First of all, we did some more limits involving some just algebra. You know, sometimes you have to factor it out, factors cancel, and it's nice and lovely, right? Then we did the conjugate, which was a special case of that, where you have radicals, right? Where the conjugate of the square root of x plus a plus b becomes same square root minus b, and vice versa, with minus b becomes plus b. And we multiply by that over itself, because it's still multiplying by 1 technically. All right, so that covers what we did. There was a lot of good examples. Now I'm going to leave you with 5 more examples over here via movie magic that you're going to maybe do for practice. They're all worth a quick glance. It shouldn't take you long. But yeah, with that, thank you for watching. I'll see you in the next one. If you found this helpful, leave a like, maybe subscribe. If I wasn't helpful, comment below how I can improve. Feel free to dislike if you think I was bad, but otherwise, thank you for watching, and I'll hopefully see you again.